Hey everybody, so I figured I'd start back up and see how many I can get done before I have to go to directed study. So I think I can get at least one or two of these done. So this is number 5 in the practice test. So this equation represents the ideal gas law where T is the temperature. We have an equation, P times V is equal to N times R times T. Rearrange the equation to solve for T. So we know what we're doing, we're solving for T. And they give us an example of T equals blank, and we're supposed to put the answer there. So this is definitely a spot where you'd want to be using your scrap paper. And this is an example of a literal equation. So for those of you who remember that in algebra, it's typically an equation we associate with multiple variables. So we're just trying to get T by itself. We're trying to isolate the T. So I'm going to rewrite that right here. So PV equals nRT. All right, so T is what we call our target variable. Let me zoom in a little more so you can see that a little better. This is what we call our target variable, right? We want to get this by itself. So how do you get this by itself? Well, you need to move the other items that are on the same side, equal sign, to the other side. We're going to use inverse operations. So we have N times R times T. These are all being multiplied together. So we're going to use what's called the inverse operation. And the inverse operation of multiplication is division. So we're going to divide both sides by N and R. Okay? So that'll cancel out. We're going to have T equals PV over NR. And that's it. So now here's the thing though, when you're doing this on your computer, because you should be, as you're doing this, as you're writing this down, you should be also following along on your Chromebook and doing the actual problem digitally, because the interface is part of the challenge. So make sure while you're doing that, I should remind you at the beginning of each of these videos, make sure you're following along on the website, which is linked in the description of this video, okay? Don't just write it down. Also, write it down while also doing it online, because that way you'll see what I'm talking about. So when you enter this in here, let me zoom in a little more, there's going to be options of how to create a fraction, and one of them has a little box over another box, and that's how you'd write this here. So PV over NR, okay? And that's the solution. Let's look at the next one. Number 6, okay. Oh, I like this one. Okay, here we go. So this is what we call a composite transformation. There's another word for it. There's another phrase for it I'm forgetting. Composite transformation, sequence of transformations. You know, there's a few different ways of saying it. Let's go ahead and read what it's asking us to do. Triangle ABC shown will be reflected and then translated. So it's reflected across the x-axis, and then it's translated 3 units up to create its image, triangle ABC. Now I don't like this because technically when you reflect it, that should be the first image. And then there should be another image afterwards. So technically, I think this should be A double prime, B double prime, C double prime. But that's just me being a math snob. So we're going to reflect it, and then we're going to translate it. So we're doing two things. Okay, so this is our pre-image, and our resulting image is going to be flipped and then shifted, right? So flip and then shift. Probably can't see that. Let me zoom in here. We're flipping and shifting, right? So we're reflecting across the x-axis. So again, you can't, like when you're doing this on the computer, as you should all be doing now, you can't draw the way I'm drawing here. But you could sketch it. You could say, okay, here's on a piece of paper, here's what it looks like. I'm going to flip it that way. Just a little notation. I can't see what I'm talking about. But you could sketch something like that. You draw a little triangle, say, okay, I'm flipping it. It's going to look something like that. Just a rough image. So then when you're doing it, you can verify that you're doing this correctly. All right, so we're going to flip this. So A is going to stay where it is. C prime should be right here. And then B prime is, see, 1, 2, 3. So 1, 2, 3. There you go. And that's B prime. Oops, there we go. So that's the first part. Then we're going to shift it 3 up. All right, so we flipped it. Now we're shifting it 3 up. So I'll use red for the other one. So 1, 2, 3. And then 1, 2, 3. And then 1, 2, 3. Okay, so B prime, A prime, C prime. So this is the one we want right there. Okay. So now you'll notice they don't really give you any means of writing in the coordinates. They give you 4 pictures, right? So what you can do, you can actually you can solve this very quickly if you know it well. So we know we're reflecting it, then we're shifting it. So we know when we flip it, we're going to change its orientation. And we know when we reflect it over the x-axis, all the y values become opposite signs. So we know this is literally going to turn it this way. So if we look at these pictures, we can immediately cross some of these out, because we know when we shift it, we're not going to change its actual orientation. We're just going to change its positioning, right? So we know B, when we flip it, will be the highest point, right? When we look at this and it's flipped, B will now, which was the lowest, will now be the tallest point. So if you look at these four options, this is the only one where B is the tallest point. It's the only one, right? It has to be that one. So then we would have to spring it over and then slide it up. I think sometimes it might be easier for some students to take different ones and see what fits. But really, this is the only one that would fit here and look like a reflection. None of the others would work. So once you do that, then it's just a matter of dragging it up, as I hope you're looking on your Chromebook as you do this. But yeah, that's all it's asking you to do, is to be able to do those two different transformations. What's next? What do we got? Oh, okay. This one is probably going to give some people a hard time. This is probably going to challenge some folks, because this requires a fair amount of memory. If you don't remember how to do this, and I hope you've been practicing this stuff. If not, this example should help you. Okay? So let's take a look at what it's giving us here. It's giving us four different expressions, and it's asking us to identify them as either rational or irrational. So one, we need to know what that means, like the differentiation between the two. One, rational means it can be expressed as a fraction. Okay. In other words, the top value could be divided by the bottom value. And there's an example here that it almost goes against what that definition of rational is, unless you think really deeply about it, which you'll see. And irrational numbers cannot be expressed as a fraction, or it cannot be a ratio that actually works. So let's take a look at this one. We have 3 radical 9 times radical 2. So we can simplify this, and that's what you're going to end up doing. You're going to end up writing these down on scrap paper and testing these out. So 3, let me zoom in here. So 3 radical 9 times radical 2. Okay. Well, I can simplify that, because radical 9 is actually 3. So this is going to become 3 times radical 2. And that's 9 radical 2. And radical 2 cannot be written as a fraction, so therefore this is irrational. So this would be irrational. Okay, so far so good. Now this next one is radical 9 over pi. So radical 9 over pi. Oops, let me zoom in a little more, sorry. So radical 9 is actually just 3. We can simplify that. So 3 over pi. And can you divide anything by pi? No, because pi is a number that goes on forever, no discernible pattern. So no, you can't. This is irrational. So yes, this is written as a fraction, but only because we're using a symbol to stand in for the value of pi. Pi is an irrational number because it goes on forever in no discernible pattern, right? There's no ending to it. It goes on infinitely, as does radical 2. If you try to find the square root of 2, it'll go on forever. So you know you cannot divide by pi. Now if you had a pi on top, they'd cancel out, then you could do that, which you might see coming up. Okay, next one. So pi times radical 24 over the square root of 6 radical pi squared. Okay, so let's try this one. So pi times radical 24 over square root of 6 pi squared. Okay, let's simplify this. So we know that 4 times 24, yeah, let's do that. So radical 24, I'm actually going to break this down for people that maybe aren't as comfortable with it. So let's go ahead and break these down into factors. So 2 goes into 24 12 times, 2 goes into 12 6 times, and then 6 has 2 and 3. So those are all our prime factors. Okay. So let's change radical 24 to this. 2 times 2 times 2 times 3. And hopefully this rings a bell. So we're looking for numbers that happen twice because this is a square root. So we have a pair of 2's, cross those out. Let's bring them on the outside. We still have the 2 times 3, which is 6. So this is actually 2 radical 6 is equivalent to radical 24. So we're going to replace this radical 24 with 2 radical 6. Why, you ask? You'll see in a moment. So 2, and we still have that pi. So 2 pi radical 6. And we still have this right here. We have 6 square root of 2 inside. So we know pi times pi is pi squared. This is actually, you can simplify this. You can cross this out and bring a pi on the outside. and still leave the radical 6 there. Okay? Hopefully you're still with me, because this one's kind of tricky. So again, we simplified the radical 24 to 2 radical 6 and wrote that there. We still had the pi on the outside, so we had to write it. I should use a different color so it separates a little more. And then here we just took pi times itself, because if you wanted to, you could do it this way. You could say, all right, well, pi times pi, right, times 6, and the pi is on the outside. That's the longer way of doing it, but that's how we got there. And now we can simplify. So we know these cancel out. We know those cancel out, leaving us just 2. So yeah, 2 is definitely rational. So it's pretty nutty when you think about that that's actually equal to 2, which is kind of funny. All right, so negative radical 3 plus 2, that is irrational. That is irrational. A rational number plus an irrational number will always be considered an irrational expression. Okay. All right, so that's that. And then let's go down here. Now these actually give you the option. These say when you click, because you should be looking on your computer, this one says rational or irrational. This says because one of or all the terms, and then this says rational, irrational. So again, this is actually just kind of a further explanation of something like this, because this is very similar. We have a rational number and an irrational number being added together. They don't cancel out. Some students might look at this and say, oh, these equals 0. No, this is radical 1. This is the square root of 1 8/10, whereas this is just 1 8/10. So this is a different number, right? All right, so we're going to say this is irrational for the same reasons that this was irrational, actually. This is irrational because one of the terms is irrational. So again, this is probably, of all the problems we've done, this might be the most challenging one for us at this point. Which number was this? This was number 7. Okay. All right, we're going to stop there, guys, because I'm about to run out of time. I got to run down to the auditorium for a directed study. So tomorrow, I have a full prep, so I should be able to get. How many more do we have here? We got. Let's see. We got 8. So 1, 2, 3, multi-part. Yeah, I should be able to finish this tomorrow. I'll probably stick to making the multi-parts their own videos though, because they're so expansive. So let me know about this one. I know this one might be confusing for a lot of us, but hopefully we feel better about it. All right, see you guys soon.